The word today is curve, big for crane users because you probably get it in two, like I did. Greeks, big into curves, mathematical curves in particular. They weren't really that into curves as much as they were into lines, and their study of lines led them to find a bunch of mathematical curves. Don't ask me why a mathematician, specifically Euclid, sat down one day and was like, hey, how do we cut a triangle in half? You can say, okay, you just cut it down the middle. And which is, that's all well and good, but how do you mathematically find the middle of an angle? You can't just eyeball it, right? It won't be as accurate, and then, well, nothing will happen. Nothing will happen if you can't do that. But sometimes that kind of precision is necessary, right? So this is how we did it, right? So we draw. Let's pull this up. So we draw an angle. We'll take two lines and have them connect at a point here. We take an angle. Any single-jointed angle, any angle, Euclid calls these rectilineal angles, and you label each point A, B, and C, right? Now any point along the line in between A and C, I want you to write D. Write D here. Now, parallel to D on the AB line, write E. So we write E. Now connect those two with another line. Don't worry. That's halfway there. Don't worry, this isn't the thing, right? So now take that line we just drew and make a triangle with it. To make it as inaccurate as possible, we'll do this where we're take the angle and draw it out all the way to the end. And then we'll take an angle, draw it all the way out to the end. And I don't know if this is accurate or not, but Euclid says that halfway point would be in between, would be at the F angle. I've drawn it badly here. I've probably done it quite wrong. This is in Euclidean space, which means like perfect, right? And I am not a perfect human. So, it's supposed to be inherently more accurate than eyeballing it, though, right? This, however, requires you to have a completely equal D, E, and F lines, and so it kind of like defeats the purpose in my head. But I guess that's why I'm shirtless making YouTube videos and not olive oiled up arguing about angles. Thousands of years ago. They did a better job with semicircles and a compass a while ago, but I'm not going to do that. Anyway, so this wasn't the main issue where the curves come in. It's actually when someone sat down and was like, wait, what if we tried trisecting these angles? What if we tried to take this angle and cut it up into three? To which I assume math people sat down and cried, knowing that their task was Sisyphean. Now, I was getting a lot of mixed messages on the internet about if this was possible. Everyone was saying it was impossible, and then some people were saying you just use a spiral, a la this bad boy. Use a spiral here, but another guy says that splitting up the triangle horizontally, right? It means you can't plot every point on the graph, and therefore there will always be a section of the angle. Because, right, we're not talking about a triangle necessarily. We're talking about an angle, which is open, right? There will always be a section of the angle which is larger than your last sections. And so, okay, so you can't do. It has to be, parallel to the A point. You have to start at A, and you have to divide it up into three. Using those points, right? So there's a hatchet tool and everything like that, but a guy has already gone off. Pierre Wansel, I think he's French, goes in pretty deep about it, and this is the heaviest math paragraph I've read since high school, which says it's impossible to make a 20-degree angle, so you can't split a 60-degree angle into three. So it's impossible to solve the problem of, and this is the plainest way I can say this problem, create a system that can trisect any angle using a straight edge and a compass. We're going to read through this paragraph, and you can figure this out, because I'm missing some basic linear algebra concepts like minimal polynomials, which is right here, right? apparently this is an algebra concept, a linear algebra concept, and I just don't have that in my head, and I won't be able to take the time to make this video, as good as I want if I don't have that base in my head, right? So denote the set of rational numbers. Where is it? This is the wet cell. Denote the set of rational numbers by q. If 60 degrees could be trisected, the degree of a minimal polynomial of cos 20 over q would be a power of 2. Now let x equals cos 20 degrees. Note that cos 60 degrees equals cos pi over 3 equals 1/2. Then by triple angle the formula, cos... you lost me. You lose me here. What is a triple angle formula? Really, really interesting stuff. But all that to say, right? I love when there are words in the world and words in the world that take you on these kinds of paths where you look at something, you realize, oh, there's so much I don't know. I'm just really dumb. Anyways, I hope you got the Worlde today in 3, and I'll see you tomorrow.